So today we're going to talk about comparing two linear relationships in various representations such as equations or graphs or tables to answer a problem. So when we talk about comparing, we have the idea of which one's bigger or smaller, that type of thing. We're still going to use our rate of change. And we know that it's the same as saying slope. All right, so we still have this in our back pocket as we're learning some of these things. So a green hot air balloon is rising at a constant rate. Constant rate means linear. After 2 minutes of its height, 2 minutes, its height is 30 meters. And after 6 minutes of its height is 75 meters. A blue hot air balloon is rising at twice the rate as the green balloon. Determine the rate in meters per minute for the blue balloon. So when we're looking at this, we're looking at two scenarios. We've got the green balloon. All right. And we could do this in multiple ways. We can plot it on a graph, or we can make a table. So what do we know? Well, if we were looking at minutes, we know after 2 minutes, its height is 30 meters. And we also know after 6 minutes, its height is 75 meters. These are all minutes. All right. So we have to ask ourselves, what do we want to find? Well, we have a blue balloon. All right. It's going to rise at twice the rate. So when we hear rate, that should tell us that we're finding our rate of change or slope. So if we can find the rate of change for this, we just have to double it. Okay? And we could use the graph to answer this question, or we can use other skills that we've learned from rise over run or finding the slope, whatever way that would make sense. So if you know how to do this, push pause and give it a go and see if what you can come up with for the rate of change in green, and compare that, and then we will double it for blue. So hopefully that when you were doing the rate of change, you were looking at rise over run. So this is our rise, this is our run. All right, so with my calculator, I can say that has gone up by 45 meters over 4 minutes. So now we can say is our rate of change, rise over run, is 45 meters over 4 minutes. And you could divide that out. I could take 45 divided by 4. All right. That one's 11.25 meters per minute. What we need to do is find the double the rate of the green. Well, if we know the green, it rises at 11.25 meters per minute. So we know the blue is twice the rate. Well, we can do 2 times 11.25. And if I do that, that'd be 22.5 meters per minute. So where the idea here is we're using rate of change and we're making modifications from one quantity to another quantity. And we could do the same thing of this on the graph. So you're a person that looking at a graph, you could do that. So after 2 minutes, I'm at 30 meters. And then after 6 minutes, I'm at 75 meters. And I can do that. I can actually draw a line. All right. I can draw a line like so. All right. You notice there that it didn't start on the ground. That's okay. It doesn't matter. But this one was the green one. And we can find the rise and run. But we know that the rise and run represents the same thing that we did here. Here we went 4 minutes this way, and this way we went up 45 meters. All right. So different ways of doing it. My slope here is still going to be 45 over 4. So the answer ends up being the same. So hopefully that two different ways of looking at it, still getting the same answer. All right. Here's a second example here. The relationship between the distance between the surface and the time for 2 scuba divers is shown below. How much faster is diver B diving versus diver A? Well, when you're looking at faster, you're looking at rate of change. So if we can find the rate of change of this one and find the rate of change of this one, then we can find the difference. So what I'm going to do is I'm going to push pause, let you try finding the rate of change for both of those, and then we'll compare. So go ahead and push pause. So hopefully when you found your rate of change, you ended up finding the rise and the run for each of them. So I noticed here, I picked 2 points, started at 0, 0, went up to 3 and 24. It ran for 3 minutes for 24 meters. I found that the rate of change here was 8 meters per minute. Did the same thing for diver B. So this person went down 60 meters in 6 minutes. So there. And I got 10 meters per minute. So you look at that and say, well, okay, should it be answer C? No, we want to find how much faster did diver B versus diver A. To find how much faster is we can subtract these. All right? To get my answer there. Okay? So again, we're comparing rates of change. This one we were subtracting because we wanted to find the difference between the two speeds of the divers. Okay. Here's another example. Karina wants to rent a snowmobile for a day and considers 2 rental companies. The relationship between the total cost of renting Trails R Us, which is in the graph. So we're looking at total cost and the kilometers is represented below. Off-Roads charges a flat fee of $90 with unlimited kilometers. How many kilometers is the total cost and same in the both rental companies show your work? So for some people, okay, they might want to put that information on the graph. What does that look like on the graph? Well, $90 is going to charge me $90 for as many kilometers as I want to go. Well, someone might ask me, okay, what does that represent? Well, you want to ask yourself, all right, if I drive 0 kilometers, it's going to be $90. If I drive, say, 40 kilometers, it's still going to cost me $90. You can probably take a guess what the next one's going to be. You're probably right, it's $90. It's consistent, it's flat. And by doing that, what I can do is actually draw a horizontal line at $90. So this one is off-road, so this helps us to label things, and this is something that in the future when you're actually doing your graphs, it's nice to label them so that you can have a clear picture of them. So the question now is, what's the answer? How many kilometers will they go? Is the cost the same for both companies? Okay. So I'm going to push pause, write down what you think, give it a go. Hopefully you said that 80 kilometers is the same number of kilometers that's going to cost $90 for each. The question is, why is that the answer? Well, there's two ways of understanding that. What's called the point of intersection. And the point of intersection is saying that if I look at this line and this line, this point is a common point between those. So we look at that point, and we can say to ourselves, well, that point of 80 kilometers and $90 is the same for both. So that's one way of looking at it. Another person might say, well, is there an algebraic way or using algebra to do it? And the answer is yes. We know that for, let's do blue here, for off-roads, we have an equation, C equals $90. Because the cost is $90 the same, and for this one, there's no rate of change because it's a flat rate. But if I look at if I look at Trails R Us, we know how to make an equation on that line. Well, we know our initial value is $30 because we can see that at that point. We can also find our rate of change. And we're going to pick a common point. Heck, we can even use those 2 points because we know that they're common. All right, and I can use my run. My run is 80, and my rise is from 30 to 90. So that was plus $60. So my rise over run is $60 over 80 kilometers. And if I reduce that, that's 3/4 or 75 cents. Move that up so you can see it. So I can say that my equation for this one, 30 plus 75 cents per kilometer. And I want to show this to you because in grade 10, as you move on, you're going to be solving equations where you have 2 scenarios. Well, if the cost is the same, this cost here and this cost here have to be equal. So C1 must equal C2. And for those people that see this algebraically, I can sub that in. $90 equals 30 plus 75N. And what I can do with that is now I can solve an equation. So here using our solving rules. 60, so I'm moving the 30 over to the other side. So I have all my like terms together. All right, and I know that I have to divide out. We better hope we know what the answer is. If I went to my calculator, so that I'm not lying to you, if I do 60 divided by 0.75, I get 80. That's a good thing. All right. So here, if I was looking at the cost for 2, if I was doing 0.75 times 80, there's 60, well, that's $90. And we know that C1 is $90. So I still arrive at the same solution. All right. So for the purpose of learning in this class, okay, this probably wasn't necessary. But I wanted to show you that because this is going to lead into grade 10, but it makes the connection from the stuff you did in grade 9. So if you were trying to compare when two things are the same, we find the point of intersection. And we can find the point of intersection to see where the two lines cross. And if you're a person that wants to see that plugging into Desmos, all right, plug these two equations into Desmos. C equals 90 and C equals 30 plus 0.75n. And then if you hover over that, all right, you would see that you would have a common point. All right. Show you one more. Here we go. So Jillian's got 2 bank accounts. After speaking with her financial advisor, she decided to start a savings account by putting $100 away per week into that account. Jillian also has a checking account she uses for her college expenses. That is this graph. The question is, at what number of weeks will Jill's savings and her checking account have the same amount? The question is, point of intersection. Okay, so if I'm looking at this, we know that this line on here is already her checking account. So the question now is, how do we figure out how much is in her savings account? Well, for some people, they might do a table. Some people may do an equation. Some people may put it over here and graph the line based on these two. All of them make perfect sense. All right, so what I'm going to do is I'm going to push pause. I want you to determine what the table will look like, maybe based on some of these numbers. So if I was doing maybe 0, 8, 16, determine how much money is going to be saved. So what I did was I chose those numbers, but you notice there that it's $100 per week. That's my rate of change. I don't start with anything in my account, so I have no constant. And what I end up doing is plotting these points. So I plotted 0, 0, 8, 8, 800, 1600, and I drew a line. All right. So you'll notice there that now we have both graphs on there. We can take a look. All right. So we needed to find the point of intersection. All right, point of intersection is there. Take 2 seconds, write down what that point is. And then push pause, and then write down the point, come back and check your answer. So my point of intersection was 20 and 2000. But we need to know what that means. Well, we knew that this was weeks and this is money. So this means 20 weeks, I'm going to have $2,000. All right, so if I was making a nice therefore sentence, I can say in 20 weeks, Jillian will have $2,000 in her savings and $2,000 in her checking account. So there we go. We're talking about comparing two relationships. In this case, we're talking about when will each of the relationships be equal. But that's what we're kind of looking towards. Hopefully that's helped. Give the practice a go and then go from there.